Next part of 3.5 is what happens to actually create a second horizontal asymptote. Everything we talked about in the first video either had one horizontal asymptote or none. It is possible for a function to actually have two horizontal asymptotes. Now, this is only going to happen if you have a square root. I guess technically it could happen with a fourth root, although I've never seen anything show up. It seems like square root's the common one. If you have a square root in either the top or the bottom of your rational function, you will create two horizontal asymptotes. The reason is, and you might be sitting there going, well, why? Well, think about what happens when you take the square root of a value when you're solving an equation. You get two answers. If I have x squared equals 9 and I square root both sides, you get plus or minus 3. Same idea applies here. So if you look at this particular function, 3x minus 2 over square root of x squared plus 1, you do have the same degree. When you take the square root of the bottom, you end up with just an x to the first power. The difference with my asymptotes, it really just depends on which direction I'm heading. If I'm heading in the positive direction, I get a positive limit of 3. If I'm heading in the negative direction, I get a limit of negative 3. But what happens when you put it all in one picture, this is just the graph of the function here, you'll have end behavior going on both sides flattening to a different height, flattening to alternating heights, really. So this side, it's flattening to y equals 3, and on the left side, it's flattening to y equals negative 3. The other thing to notice, a lot of times students think that a graph can't actually touch or go through a horizontal asymptote. It actually can. It's not like a vertical asymptote where you really have nothing there. The horizontal asymptote is really just serving as like a guide. It's basically kind of guiding you to the right or guiding you to the left. So if you have square roots, you have the potential of two different horizontal asymptotes because of the square root giving you a positive and a negative solution. So I want to show you some examples and kind of help you with maybe some of the pitfalls that students run into. The first three were just previous examples from other years, and then the last one, you can tell the font is a Delta Math question. So for the first one, first thing you want to check is, do they have the same degree? So because the numerator is a 4x squared, it's good, but the bottom is also going to be an x squared because when I square root an x to the fourth, I get x squared. The number one mistake that students make is they forget to also square the coefficient 9, so square root the coefficient 9. So your answer here is 4 over 3 because you have to take the square root of the coefficient, and that is the number one mistake students make. If this was asking to go to positive infinity, so it was just asking the right end behavior, if it asked the left end behavior, you would put negative 4/3. Or if it asked for horizontal asymptotes, you would put both positive and negative 4/3. Second one, this is another common mistake. And when you look at it at first glance, you think, oh, well, same degree, we're good to go. But the issue is when you take the square root on the bottom, you actually don't have the same degree anymore because you're going to have a second degree on the top and you're only going to have a first degree on the bottom. This is one that the top is growing faster, giving me an infinite answer, meaning I don't have a finite limit that exists. I also don't have any horizontal asymptotes. Visually, they look like they're the same degree, but you do have to take into account the square root before you determine that. Third one, again, check to see the degree. If I take the square root on the top, I will just get an x. If I take the square, or the bottom is already an x, so it will get a finite limit. Don't forget to take the square root of 16, which is 4, over 2. But then you have to keep in mind that this one wanted the left end behavior. So instead of a positive 2, you're actually going to get a negative 2. This one would have two horizontal asymptotes, one at y equals negative 2, one at y equals positive 2. And then I wanted to show you this one just because it came from Delta Math. So this one is asking to take the square root of, we're going to look at this leading term. So when we do that, we get 5x to the third because you're going to do 6 divided by 2. The bottom, the leading coefficient, the leading term is 3x squared. So this one also has a bigger degree on the bottom, meaning a finite limit does not exist. So that's how we deal with square roots. You have that potential of having a second answer.